Hello, Algebra 1. Today we're looking at lesson 7.5, comparing linear, exponential, and quadratic functions. All right, so we're going to look at this a few different ways. We're going to tell the difference between these functions by looking at graphs, looking at tables of values, and then also just by looking at the function. And also being able to write a function based off of the data. So this is kind of interesting. If you recall, a linear function, when you graph it, it's a line, and a common format for that is y equals mx plus b. So we got linear right there. An exponential function has this kind of, it's got exponential, it's got a growth factor. Sometimes it has a decay factor, but it's got this curve shape. It's not a parabola, but it's got this curve shape, and it'll continue getting steeper as it goes. It's kind of interesting. But that those functions, x is your exponent. And then finally, we've got a quadratic function. And quadratic functions can be pretty basic. They can also be pretty complicated. This is the more complicated version. This is standard form right here of a quadratic. Degree 2. So these are quadratics. And when you graph them, they have that parabola shape, that U shape. All right, so first things first, let's use graphs to identify the functions. And that's as simple as just plotting the points and seeing what you have. Okay, they kept us guessing there till the end. They didn't have the points in order from left to right, and so it was kind of confusing what it could be. But it turns out if we connect those points, we've got a parabola. So this is a quadratic. And let's move on to the next one. All right, what does that look like? Well, if we connect them, we can see pretty clearly that is a line. So this is linear. So yeah, it's as easy as that. Let's go on to talk about the table of values. This can be a little more tricky, okay? It says, yeah, let's review this up at the top there. It says differences and ratios of functions. It says you can use patterns between consecutive data pairs. Consecutive means there's no spaces in between, I should say, I guess. -1, 0, 1. It doesn't skip any x values, so consecutive data pairs to determine which type of function models the data. The differences of consecutive y values are called first differences. The difference of consecutive first differences are called second differences. Now, the reason they mention that is that comes into play with quadratics. It doesn't come into play with the other functions, but we'll see what's going on with that. So a linear function, the first differences are constant. For an exponential function, you're going to have a common ratio. It's not going to be differences, it's going to be a common ratio. And then finally with a quadratic function, it's not going to be either of these. And if you were to find the second differences, they're going to be consistent. They're going to be constant. And they remind you here, in all cases, the differences of consecutive x values need to be constant. They should be consecutive, ideally. Okay, so tell whether each table of values represents a linear, an exponential, or quadratic function. Now I want to be clear, these are coordinates. You could grab some graph paper and graph it and see. But another way to do it is to look for the patterns. Double check consecutive across the top, that looks good. And then ask yourself what the pattern is across the bottom. And yeah, you can see, I think pretty quickly, that the common difference, 8 minus 11, 5 minus 8, 2 minus 5, negative 1 minus 2, is negative 3. They are adding a negative 3 each time. And because that's a common difference, that means this is what? That's right, it's going to be linear. It's going to be linear. And then, yeah, we're not going to write the equations, but if you were to write your equation, turns out this common difference would be your slope, and 2 is your y-intercept, and you would get y equals negative 3x plus 2. But it turns out that's not really one of our goals today. But for those of you that kind of know what I'm talking about, there you go. Okay, notice up on our next one, consecutive values, looks good. And then let's see what the pattern is. It could be, the common difference could be 1, 2 minus 1 is 1. But if you add 1, yeah, it doesn't work out, and so it doesn't have a common difference. So then we look for common ratios. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So what they're doing is they are multiplying by 2 each time. 2 is called the common ratio. Common ratio. So that means this is exponential. It's exponential. And I can go ahead and show you how to write the equation. The common ratio is your growth factor. So it's going to be the base of the exponential function. And then the y-intercept right there is kind of like a leading coefficient. So that would be the equation for that one right there. But you don't have to stress about that. And then on this last one, we've got consecutive values here. And let's see what the pattern is. So it could be common difference of negative 1, but negative 1 does not work for the pattern, so it's not linear. It could be that they're multiplying by 2. Common ratio here is 2. That doesn't hold up. Okay, so here's the thing, class. It's neither. And as soon as it's neither a common difference or a common ratio, you're going to know right away that it is a quadratic. Okay? You're going to know. But here's the interesting thing. Let's get the difference between each one. So you would subtract 1 to go there. Negative 1 minus a negative 2. That's plus 1 to go there. You'd have to add 3 to get to 2. You'd have to add 5 to get to 7. Notice nothing's in common there. But then if you do it a second time, check this out. 1 minus a negative 1, that is 2. 3 minus 1 is 2. 5 minus 3 is 2. So the second difference will be common. Isn't that interesting? Now, does that number help you at all? No, it doesn't. It just verifies that, yep, this is in fact a quadratic, which might, it might come in handy sometime. If you had some that could be none of the above, the second difference would be valuable to figure out, because it may turn out the data is none of them. But if you're forced to be one of the three, as long as it's not linear and not exponential, you should be good with quadratic. All right, well, hopefully you enjoyed this lesson. Have a great day.